Is it audible?
Yes, sir.
So good afternoon to one and all. So after so many days, we are engaging the class. Yes, almost 10 to 12 days. So we have started already. I think third unit is started. Yes.
Yes, sir.
Okay. So the unit 3, that is potentiometer and bridges. I already told that one, the basic principle of potentiometer is over, and some bridges we have covered the practical with all whole derivation and all the things. So it will not take much time to finish this unit. Okay. So here this up to this one. Introduction of DC potentiometer. We have already discussed. Then also for your kind information, what do you mean by potentiometer? So it is a potentiometer, an instrument which one we have designed to compare the unknown voltage with the known voltage. Okay. Example, what do you mean by calibration? Calibration is the same thing. We have to compare the unknown voltage with the known voltage or standard voltage. We are going to call that one. If it is getting same answer of the unknown voltage and standard voltage, both are same, the tool is perfect or accurate. We can say that one here. Like that, for that reason only, the potentiometers will give the accurate answers. For that reason, we are going to use this potentiometer for any term in measuring the voltage, current, and all the things over here. So here a potentiometer as an instrument designed, it is designed for measure an unknown voltage. Unknown voltage measure करने के लिए हमने use कर रहे हैं, which this measured unknown voltage is compared with the standard voltage. We can provide the standard cell, we will provide that one. The same voltage it is there or not, we can measure also here. So that purpose we are going to use the potentiometer here. Now known voltage may be supplied by a standard cell or any other voltage reference source by standard cell supplies कर सकते हैं. So this one also we have considered a long cable LAB, that is total LAB, the long cable or wire I have considered, which is a uniform cross sectional. Here the cross sectional of that wire is same, here the same, here the same, but the total length is AB. I can measure here. I will provide the supply of E here now, and this rheostat voltage, by varying this rheostat we can control the current. I will fix one current, suppose 5 ampere I will provide here. So cross sectional area is same here. So cross sectional area is same for the length AB. So R equal to rho L by A. You can call that one. R equal to rho L by A. R is directly proportional to L and inversely proportional to area is there here. So the anywhere at the AB terminal here, the cross sectional area of the AB is same at all the places here, no? So it is constant here, no? So the resistance of this AB is depending on the length of this one. How much length we will consider, depending on that it is going to vary. So the resistance depending on the cross sectional area, here it is same, here it is same, here it is same. But we are going to measure the voltage drop across particular point only, from A to B here up to this point you want to measure. And that situation, the voltage drop across this one is directly proportional to this length A to I we can consider here. This total length, it is going to depends here. It is dependent on that one. We are going to say, already we have discussed this term. Then also I am telling here. So this is the just construction diagram we have used here now. If a wire of a uniform cross section, the uniform cross section wire we have considered is carrying a steady current. Steady current means the constant current it is going to consider here now. Then fall of potential across any portion of the wire is directly proportional to that length of that portion. Fall of potential across here now. Up to A to C, the potential drop I want to measure. This potential drop is equal to the length of this conductor here. Now, how much length we are considering? This one here. After here only we are going to consider here. Okay, is it clear or not? Example I have given yesterday in the last class. I have already given the example over there. Suppose you consider one hostel is there, 100 students are there. Okay, 100 students are there. Every day they are going to give one banana over to all the peoples. Okay, next day, suppose 50 students, they will not come. The 100 banana 50 students को कितना कंज्यूम हो जाते हैं? हर एक को 50 होते ना? Yes or no? Daily
Yes, sir.
50 स्टूडेंट्स तो गांव को गए, सोचो अभी घर को गए 50 होते हैं. ऐसा हमारे पास लेंथ एक कितना है, ये भी है लेंथ, हमको इतना ही चाहिए. ये एसी तक की हमको वोल्टेज ड्रॉप चाहिए. वोल्टेज ड्रॉप अक्रॉस दिस ये भी इस टोटल कंसिडर हो जाते हैं, बट इतना ही चाहिए मींस टोटल लेंथ को हमने डिवाइड कर सकते हैं. 100 डिवाइड बाय 100 इक्वल टू 1. पर स्टूडेंट को 1 आ जाएगा, फिर इनटू 50 किया तो इनटू दिस L1. वी कैन डू दैट वन. यस और नो? By doing this one, that is the voltage drop across particular area or particular length, we can measure here. Now for that reason only we have used this formula here. We know the formula already, R equal to rho L by A and V equal to IR. In this place of R, we can substitute rho L by A. Rho L by A we are going to substitute here. Now the rho is constant, current is constant, cross sectional area is constant. Yes, we have already know that the rho is constant here. Now the rho is resistivity of the material is constant. Cross sectional area of that complete conductor is anywhere it is constant only. Uniform cross section area we have considered, that is also constant. But the length is varying here. Now we are not considering complete AB, we are considering some part of AB only, so that is not constant here. And the current flowing through that will be constant only. By varying this value of rheostat, by using this rheostat value, we have set at 5 ampere. That 5 ampere current only we are getting here. So I is constant, rho is constant, A is constant. Then what is the voltage drop across that particular length is directly proportional to that length of the conductor. We can say or not? Yes. So particularly if I, rho and A are constant, then voltage drop of that particular area is directly proportional to that length of that section we are going to call here now. Length of that section. That one only we have discussed in the last class. Up to here we have discussed, I think. Yes. Up to here we have discussed. Yes or no?
Yes, sir.
Okay. Some messages are coming. So next we'll start a new concept. That is, instead of straight wire, we have used one straight wire we have used here. So what do you mean by potentiometer? Anyone? Just now we have told. Potentiometer means what? Can you tell me, any one of you? What do you mean by potentiometer? It is an instrument which one we are going to compare the unknown voltage with a known or standard voltage or standard cell voltage. Yes. To measure the unknown voltage we are going to use, which one we are going to compare with a standard voltage or standard cell voltage we are going to call that. It is correct or not? Calibration purpose we are going to use. See here. Without this, I will use one circuit. Just a minute. This one, you consider this one here now. Previous circuit जैसा ही ऐसे ही है ना, ये part. अभी देखो, इधर तक. इधर एक बैटरी सप्लाई दी है हमने. इधर एक रियोस्टेट यूज किए. ये करंट फ्लो है. This is called AB. We can call that AB. है ना, ऐसे ही है ना. Previous circuit जैसा डिस्कशन किया ऐसे ही. This circuit. ये सर्किट जैसे है ना, इधर एक बैटरी है, एक रियोस्टेट है, ए बी कनेक्ट किया इधर. यस,
Yes, sir.
same circuit we are going to use basic slide wire potential. हमने इधर किधर तो सेट किया था वो वोल्टेज, दैट इज सी पॉइंट यूज किया, बट इधर देखो ये स्लाइड वायर यूज कर रहे हैं, इसको एक पॉइंट फिक्स किया हमने, बट ये स्लाइड वी कैन कनेक्ट हियर 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 एनीवेयर सराउंडिंग दिस एरिया वी आर गोइंग टू कनेक्ट. So this basic principle of the potentiometer same we are using, but to make the calibration here we have added one circuit here. This is the potentiometer circuit. This one is potentiometer circuit. This is the measuring instrument circuit here. Measuring circuit here. Main circuit this one, and this one is potentiometer circuit. The answer is no. That's very important here. See here. Whenever you don't consider this part you don't consider actually. Whenever with the battery supply is started, the positive will flow here, because depending on this variation of resistance, by setting this one, by varying this rheostat, you can set the working current. Current कितना flow करने का हमने decide कर सकते हैं. This working current I will consider as IW. IW consider करते, इधर से directly it will go to this one here, this one, and it will go back to the negative. Okay, this is the main circuit operation. Main circuit operation मालूम हो गया अभी? Yes? हाँ भी नहीं बोलते, ना भी नहीं बोलो तो कैसे करने का फिर? Are you people are interested to listen or not? समझ में आ रहा है कुछ? नहीं है तो पूछो, मैं ये भी बोलता हूँ. समझ में आ रहा है? हेलो, इज इट ऑडिबल?
यस सर.
समझ में आ रहा है क्या?
Yes, sir.
Then why you are not replying? पोटेंशियोमीटर में समझ में आ गया क्या? एक हमारे पास स्टैंडर्ड वैल्यू रहते हैं, उसको और अननोन वैल्यू को हमने मैच करना है. अभी स्टैंडर्ड, अभी सपोज आपका गाड़ी है 50 माइलेज देते बोल के है, बट वो गाड़ी 50 दे रहे क्या नहीं दे रहे बोल के कैसे कंपेयर करते हैं आप? दैट इज द पोटेंशियोमीटर पर किया. मैंने बोल रहा हूँ, मैंने 40 वोल्ट प्रोवाइड करके देता हूँ, वो अननोन वोल्टेज 40 वोल्ट है क्या बोल के कैलिब्रेशन करना है हमको. दैट इज कॉल्ड स्टैंडर्डाइजेशन प्रोसेस वी आर गोइंग टू कॉल. फॉर दैट रीजन ओनली हियर द वर्ड वी हैव यूज्ड हियर, कैलिब्रेट हियर. So that is the operation of potentiometer here. This potentiometer, this is the circuit of potentiometer. This is the main circuit here. This is the main circuit here now. So main circuit operation, from the positive the current will start to flow here now. Here one variable resistance we have used. From this variable resistance you can set the particular current by varying the current. I equal to V by R. By increasing the resistance, the current will decrease. By decreasing the current resistance, the current will be increases. So I can set 5 ampere, 10 ampere, whatever it may be as per our requirement. So 0 to 200 meter long cable wire we have used here now. This is 0 to 200 meter long. 200 meter long wire we have used here. Okay. Through that wire, the all uniform cross-sectional area wire only we have used here. The cross-sectional area of this wire is uniform only, and it is connected to the back to the negative supply here. This is the main circuit. The potentiometer, I will use two sources. I will use this unknown EMF to measure the unknown voltage at this point from 0 to 100 meter. How much voltage drop is there? 0 to 150 volt, 150 meter. Total कितना है length? Wire का length कितना है? Total length of the wire 200 meter है. 0 से 100 तक कितना voltage drop है? 120 को कितना वोल्टेज ड्रॉप है वो मेजर करने के लिए हमने एक्स्ट्रा 2 टर्मिनल्स आई हैव एडेड हियर, दैट इज कॉल्ड अननोन ईएमएफ मेजरमेंट टर्मिनल. बट आई हैव नॉट कनेक्टेड डायरेक्टली टू द सर्किट हियर. अननोन ईएमएफ I have used one point here switch, and in between I have collected a galvanometer. What is the work of galvanometer? It will sense, it will sense and it will deflect here now. And again I have provided one key here, no, one switch I have provided here. But that is I have provided 2 points in between 2 points, one switch is provided. But this sliding contact, this contact indicates that I can set this one, I can move this one here, and I can move that one up to here also. इन दिस प्लेस मूव करने के लिए हमको 90 मीटर के लिए कितना वोल्टेज ड्रॉप है, 100 के लिए कितना है, 120 को, 130, 140 को, 150 ऐसा मूव करने के लिए दिस स्लाइडिंग कॉन्टैक्ट वी हैव यूज्ड हियर. फॉर दैट रीजन ओनली सर्किट डायग्राम ऑफ बेसिक स्लाइड वायर पोटेंशियोमीटर नेम केम विद स्लाइडिंग कॉन्टैक्ट है ना, ये वेरिएबल कॉन्टैक्ट वी आर गोइंग टू यूज. दिस टर्मिनल इज फिक्स्ड, बस एक फ्लेक्सिबल वायर है, उसको इधर 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 किधर भी कनेक्ट कर सकते हैं. ओके, up to here it is clear?
Yes, sir.
Okay, this key is used once it is connected closed, then the current will flow through the galvanometer, then it is balanced or unbalanced, we can going to measure here. That one I will tell that one here. Later I will tell that one. Here this key is connected only for the sliding contact, it is used switch. But here double through is there, single pole double through means इधर भी कनेक्ट हो सकते, इधर भी कनेक्ट हो सकते, इधर भी कनेक्ट हो सकते, इधर भी कनेक्ट हो सकते. Suppose if two terminals are there, double through, 2 points are there, 2 throughs are there, one point we are using as operating mode, another one we are using as calibrating mode here. Another one is we are going to use as calibrating. In the operating mode we are going to measure the unknown voltage. The calibrating mode we are going to check that when it is correct or not. The calibration mode here we are going to check that is correct or not, we are going to check here the calibrate mode and operating mode. Operating mode में क्या करते हैं, हमने unknown EMF measure करते हैं. Calibrating mode में standard value will set that one, and same unknown EMF, that value of the unknown should be equal to the standard value here. Calibration, okay, comparing with the standard value. The potentiometer definition मालूम है, it is an instrument which will measure the unknown and compare with the standard value here. No, first we are measuring the unknown voltage, then comparing with the standard. Yes, yes or no? Problem. How much time it will take to tell yes or no? Hello, I'm asking to you people. Okay, so next, this is just I have explained the diagram how it is connected. That is nothing but construction I have explained here now. The basic slide wire potentiometer consists of a long uniform slide wire, uniform cross sectional slide wire, AB made of manganese material here now. This is the AB which is made of manganese material, which is made here now. Uniform cross sectional one wire is used here now. A graduated scale runs parallel to the wire. Graduated scale means here to here 50, 50 to either 100, 100 to 150, 150 to 200. The scale we have used here now. The end of A is this A terminal is connected to the negative terminal of the battery. The end of A is connected to the negative terminal of the battery, whose this battery terminal positive is connected to B through the rheostat RH here now. Through rheostat is nothing but variable resistance RH here now. Positive terminal is connected to the B here. So the positive terminal of the standard cell here now is connected to the calibrate mode, which is the positive terminal of the standard cell is connected through switch. Here through switch it is connected to galvanometer through key K to a slide contact here now. It is connected to the here. You can measure that one by providing this one by galvanometer detects 0 means that is this equal, we have to measure that one here. This is potentiometer circuit. This is the just construction of the circuit here. Then we'll discuss the working of this, the slide wire potentiometer, how it is going to operate here, how we have to operate this potentiometer. Okay. Some people they are joining now. How much time? This 4 half an hour already ho gaye. Okay, see here. A main circuit hai, a galvanometer circuit hai. Either switch hai. This main switch is depends on this operation. It will indicates here. Here calibrate mode, sorry, operate mode and calibrate mode. You remember that one. In the operate mode, you are going to measure the unknown. The calibrate mode, we are going to compare that one here. When the switch is in the operate position here, no, it is connected to operate position. Yes, it is connected to the operate mode, operate position, and galvanometer key is open here. No, it is not connected to this one. It is open only. Okay. The battery supplies a working current. I will switch on the battery and it will start, the current will start to flow here. That current I will consider as IW here. Working current will flow through here, through a rheostat. The battery supplies a working current IW through the rheostat RH and the slide wire. This is the slide wire here. The working current through slide wire may be varied by changing the rheostat setting here. Current kitna flow ho raha hai idhar, we can vary that current by using this one here. By increasing, decreasing, we can vary inversely proportional here now. If the RH is increased, I will be decreases. If RH is decreased, then I will be increases here now. By varying this one, we can vary the current here now. But before connecting to the galvanometer or potentiometer, we will, by varying this one, we will set the current here constant. One current will set that. The method of measuring the unknown voltage Vx, this one unknown voltage I will consider as Vx here now. This method of measuring the unknown voltage Vx depends on finding a balance point on the sliding wire. We have to find the balance point here now. Here connect karna hai kya, idhar connect karna hai kya, idhar connect karna hai kya, idhar connect karna hai. Based on that, by varying this one, we have to make the current flowing through the galvanometer zero. Null position detect karna hai humne. Either by varying this one, we have to do the null potential. Abhi already bridge circuit mein dekha hai now all of you. Potential galvanometer kaise zero karte hain humne? Varying the resistance. Yes. We have already seen in the practical. By varying this one, see here. The method of measuring the unknown position, unknown voltage Vx depends on finding a balance point on a sliding wire. Which is the balance point here? No, this is the balance point, or this one, or this one, or this one, based on the standard value we are going to identify here. The balance point, this balance point anywhere will get that one of a sliding contact such that the galvanometer shows zero deflection here. At this point we will get, or this point where we will get the balance point, the galvanometer will detect zero value deflection or null deflection. There is no current in the deflection here now. So no current in the galvanometer. When K close kiya na, when K is closed, there is no current flow here now, because it is a null deflection here now. It is deflecting the null deflection we are going to call here now. If the K is closed, then also they will not flow here now, because somewhere we are going to get the point here now which will allow, which will not flow the current here now. It will show the null deflection. That is, this is completely depends on the null deflection only here now. So if the galvanometer shows zero deflection or null means that the unknown voltage, this unknown voltage Vx is there, equal to the voltage drop across this portion, this one here. That portion AC, A to C is there, that one here now. If the null deflection means that the unknown voltage is, this unknown voltage is equal to the, suppose the pointer is here now, sliding contact is here. At this point we got the null deflection here. Null deflection we got here means that the unknown voltage, this unknown voltage is voltage drop across AC. It is equal to that Vx here to call here. Unknown voltage Vx is equal to the voltage drop across portion AC of a slide wire. This is the portion we are going to use here now. Vx equal to E1. We can call that one. Yes. This is the voltage we are going to measure. Na? That is E1 here now. The slide wire has a uniform cross section, already I have told, and hence a uniform resistance along its entire length. There is uniform cross section is there. It will not vary over there, but depending on the length, how jaisa length vary ho jata hai, aisa voltage drop vary ho raha hai. But the constant we are going to use constant resistance and constant cross sectional we are going to use here now. So entire length, uniform resistance along its entire length. The process of this process हमने adjust कर रहे हैं ना. The process of adjusting the working current so as to match the voltage drop. We are going to match the voltage drop across a portion of sliding wire against a standard reference. We are taking the standard reference here now. Is against the standard reference is known as standardization. We are going to call it. Is known as standardization. Is known as standardization. We are going to call here. So it is not over here now. Some will prove that one. Ha, jaisa ho jate, kaise ho jate. Okay. So from the main circuit, for the main circuit, here the main circuit is there. This is the battery is there. Here battery. Here the RH is there. Here the AB is there. Here this point AB is there. So the current flowing through this one IW we are going to call IW. This is RH, and this is VB here. VB. What is the formula for V? V equal to IR. Yes. V equal to IR. We are going to consider here. So I equal to V by R. What is the V here now? Battery voltage we are going to consider here. Battery voltage we are going to consider here. So the total length of this point also we have to measure. Length of resistance of this RL we can call that. I equal to VV by this RH. RH is the rheostat resistance plus LR. LR is nothing but total resistance of this complete length we are going to measure here. LR we are going to consider here. The length L into R of this resistance here. So this resistance we have to measure here. Suppose standardization means the source voltage we are going to consider. Standard voltage we have provided by using the circuit here. Just a minute, I will show that. Spotlight I will take. Here the standard cell is there. This standard cell I will consider as Vs. I will consider as Vs. The unknown voltage I will consider as Vx. So for the standardization, Vs equal to IW L1R. How much length is there from this standardization here to here? This one L1 I will consider here now. And R means up to this resistance. How much for that point? R we are considering here now. IW L1R. For the unknown resistance, Vx equal to IW working current L2. The unknown resistance कितना sliding contact किधर है वो देखने का. L2 length को कितना resistance है, that resistance here. This R we are going to use here. So from this circuit we can write IW equal to Vs divided by L1R. Can write IW equal to Vs divided by L1R. We can write. Yes.
Yes, sir.
Similarly, here also IW equal to Vx divided by L2R we can write.
Yes, sir.
So here IW equal to Vs by L1R. Here IW equal to Vx by L2R we have found here. We have found two equations here. Dividing equation 1 and 2. Dividing equation 1 by 2. I will do that one. Equation 1 को equation 2 से divide करता हूँ. Equation 1 क्या है? Vs by L1 by R. So 1 by 2. It will become L2R divided by Vx. हमने multiply कर सकते हैं इधर. Same thing I will write as it is here now. Just a minute. I will take here now. So this is one term here now. Vs by L1R divided by this complete term I will divide here. This complete term I will divide here. So this equation I can write, I will send this L2 into R. It will become multiply here. L2R. Vs by L1R I will write as it is. But this L2 into R, it will multiply and divided by Vx. I can write like this. The example of 1 by 2 divided by 1 by 4. How will write this one? I will write this one. 1 by 2 you will write as it is into 4 by 1 is nothing but 4 only. We'll write like this. Same thing I have written here. Yes.
Yes, sir.
So from this one, we cancel R and R, you cancel here now. Cancel R and R. So Vs by Vx, we can consider here now. Vs by Vx and L2 by L1. We can write like this. Vx by Vx, Vs by Vx into L2 by L1. Same thing only. This Vs by Vx, L2 by either equal to नहीं है, multiplication है, याद रखो. This is equal to, not equal to, it is multiplication here. This equation, can I write Vs L2 divided by Vx L1? Yes?
Yes, sir.
So from this one now, I will write here now, IW by IW, it is nothing but 1. IW by IW equal to 1. Is that here? Yes? I'll send this Vx into LHS side. It is nothing but Vx equal to Vs L2 by L1. I will keep as it is here. L2 by L1. Yes? You can write the final equation like this.
Yes, sir.
See here, here the very important. Vx is the unknown voltage. Vs is the standard voltage. L2 is the unknown voltage length. And L1 is the standard voltage length here. If L1 equal to L2, then unknown voltage equal to standard cell voltage. That is called standardization. We are going to call here. That is called standardization. Why I am telling means, see here, the diagram itself I have shown here now. See here, E1 is there. Same contact, same length we are using here means E equal to E1 ho gaye. E is nothing but unknown voltage. E1 is nothing but standard voltage here now. If we are getting the null position at the same point for the same length, then that is called standardization. We are going to call here now. This one here. Note, once the standardization is done, working current is kept constant. Working current हमने vary नहीं कर रहे. Only if the length of the standardization, standard voltage length and the unknown voltage length is same, then the unknown voltage is equal to the standard voltage. That is nothing but calibration mode. We are going to call that. It is calibrated. Unknown voltage equal to standard voltage means the instrument is calibrated. Correct? We can tell that one. That is the principle of potentiometer. That is the principle of potentiometer. Is it clear, the concept?
Yes, sir.
सबको clear है concept? Can I proceed for the next?
Yes, sir.
Okay. Next one, instead of straight line, straight wire, I will use some difficult wires, that is called some dial wire. I am going to use here. Circular ring we are going to use instead of straight wire here. So that is laboratory model we are going to use. In the laboratory, we are going to use the whatever previously we have discussed sliding wire. That is called general principle, general purpose. To understand you peoples, we have explained that one. This is actually laboratory model or laboratory circuit who has derived, the Crimpton has derived this Crimpton type of potentiometer. We are going to call it Crimpton type potentiometer here. See here the working battery we are using. Working battery voltage we have provided here. Same. Yes. Previous diagram को compare करो थोड़ा. We are using the battery voltage.
Yes, sir.
So we are using the same rheostat here now. This two is, there is no change. Instead of straight line sliding conductor, we have used here, see here, the different resistance values, one dial step we have used here now. Each point here now, 0 to 0.1 voltage, 10 ohm resistance is there. 1.1 to 0.2, 10 ohm resistance is there. So it is total 0 to 15. 1.5 means 15 steps we are using, 15 dial steps we are using here now. Each step 10 ohm resistance is there. So total resistance is how much? 10 into 15? 10 into 15?
150.
150. So total resistance of this dial step switch is 150 ohm. The range of voltage is 0, 0.1, 0.2, 0.3 we are using here. Now up to 1.5 volt we are using here. Here we can tell that one. This is the standardization. The standard value we have used here. No, we are not going to use any calibrating mode here. No, calibrating mode लिया ना, direct automatically we can set this one. Standard value 1.3 voltage को set करने का हमने measure कर देंगे. We can set that. So that is dial switch we are going to consider. This is circular slide wire we have used here. Now see here, this is the circular slide wire we have used here. It is also 10 ohm. Total is 10 ohm resistance is there here, but 0 to 0.1 voltage we are going to use here. So 0. We can measure, we can divide by 200 also. This is 200 also, but total ohm is 10 ohm is there here. 0.5 like band, 0.0001, 0.0002, 0.0003, 0 to 0.1 तक voltage दे सकते हैं. Okay, that is called circular slide wire. इसका slide wire का length को हमने measurement कर रहे हैं. Next, the galvanometer is connected to the slide wire here. Yes, the galvanometer is connected to the slide wire, and we have used one protective resistances at the starting. High current will flow through the galvanometer. For that reason, to avoid the damage of the galvanometer, we have used some very large resistance. 10 kilo ohm is in series with the galvanometer we have connected. Once the galvanometer switched on, less value detected, we can bypass this one. So direct connection कर सकते हैं. By closing this switch, this current flowing through this 10 kilo ohm is 0. Direct current will flow through this galvanometer here, like that here. And here the standard cell supply we have used here. Standard cell supply here. The double way DPST we are going to use double pole, double through. DPDT we are going to call it here. Double pole. How many poles are there? This is a switch here now. Double pole, double through. It can connect here or it can connect here also. दोनों at a time. A इधर है, A इधर है. देखो. Suppose this one is connected to here, means this part will connect to the here. Double pole, double through switch we are going to call it. So if it is connected to the upper terminal, then it is in calibrative mode. If it is connected to the downside terminal, that one, it is nothing but operating mode. Which one we are going to measure the unknown voltage here. For which we are going to measure the unknown voltage here. I'll just, today class I will explain the constructions only. The tomorrow class will discuss about the working. See here, this type of potentiometer is use calibrated dial resistors and small circular wire of 1 or more turns, thereby reducing the size of instrument. We are going to use calibrated dial resistors. The resistors है 0 to 0.1 volt को 0.1 volt को हमने कितना voltage है 10 volt here. Dial switch of 15 steps of 10 ohm. 10 ohm इधर से इधर 10 ohm, इधर से इधर 10 ohm, इधर से इधर 10 ohm. ऐसा हर step को हमने 10 ohm use किया. Total 15 steps are there. 10 into 15 steps, that is total dial resistance is 150 ohm is there. So calibrated dial resistance. हमने इधर regulator देखा है ना, fan का regulator है ना, fan का regulator मालूम है आपको? सब लोग देखा है ना? फैन का रेगुलेटर मालूम है क्या नहीं?
Yes, sir.
So उसको 1 में रखा ना, 0 में है तो हाई रेजिस्टेंस रहते, करंट को अलाउ ही नहीं करते उसमें, इट विल ब्लॉक्स द करंट. 1 को रखा ना, थोड़ा रेजिस्टेंस कम हो जाता है, फैन स्पीड इंक्रीज हो जाएगा. यस
यस सर.
2 को रखा तो और थोड़ा रेजिस्टेंस डाउन हो जाएगा, फैन इंक्रीज हो जाएगा, फैन स्पीड. 3 को रखा तो और कम हो जाएगा. 5 को रखा ना तो पूर्ण रेजिस्टेंस 0 हो जाएगा, ऑल करंट विल फ्लो थ्रू द फैन एंड इट विल रोटेट हाई. लाइक दैट दिस डायल स्विच वी आर यूजिंग, दिस रेगुलेटर जैसा इसको हमने एक स्विच यूज किया है इधर, व्हिच विल कंसिस्ट ऑफ 10 ohm each step, 15 steps are there. So calibrated dial resistors and small circular wire we have used here. Small circular wire, it has 1 or more turns are there, number of turns are there here now. So many turns are there inside that one. Thereby reducing the size of the instrument. We can reduce the size, reduce करने का उसको potentiometer. The circuit of simple laboratory type instrument is shown in the figure. This is the circuit laboratory type here. Now there is one dial switch here. This is the dial switch with 15 steps, each having a precision resistance. Precision resistance means same resistance they are having here now. There is also a single turn circular slide wire. This is one term circular slide wire is there. The resistance of the slide wire is 10 ohm. The resistance of the slide wire is 10 ohm is there. So the dial resistors have the value of 10 ohm each here. This value, it has 10 ohm each. So thus the dial has total resistance of 150 ohm it has here. So this is the construction of the Crompton potentiometer. Next is the working. This is the construction also. Working principle here I will tell that one. So the working of a current, working current of this one. See here, whenever I will switch on the supply, battery turn on ho gaye, then current will start to flow here. Yes, positive terminal. But this current can be controlled by a variable rheostat. I will, by varying this one, I will set the current, working current as 10 milliampere. Right, 10 milliampere. The working current of potentiometer is 10 milliampere, and therefore each step of dial switch corresponds to 0.1 volt here. 0.1 volt. 10 milliampere. What is the value of V here now? V equal to IR. 10 into 10 milliampere. Kitna ho gaya dekho? 10 into 10, how much? 100. Milli is nothing but 10 to the power of?
-3.
-3. -3 is nothing but 10 into 10, 100. 100 divided by 1000. How much it is?
0.1.
0.1. So 0.1 we are increasing here now. Here the 0.1. Each step ko kitna hai? 10 ohm hai. Yes? Based on that, the current is set at here now. The working current of potentiometer is 10 milliampere, and therefore each step of the switch corresponds to this one is 0.1, 0.1, 0.1 difference is there here. So the slide wire is provided with 200 scale divisions here. Now this one is there here. 200 scales को divide किया इधर 0.0001, 0.0002 like that. 0.1 volt है total. It is divided by 200 scale से divide किया है total. 200 scale से divided है. Since the total resistance of the slide wire corresponds to voltage drop of 0.1 here now. Total resistance of depending on that one 0.1 को हमने कर रहे. But each division 200 divisions है. Each division को कितना हो गया? Total voltage is 0.1. 0.1 divided by 200 कितना हो गया? 0.1 divided by 200, it is nothing but 0.0005 volt here. It is nothing but 0.5 millivolts. You can call that one 0.5. 1, 2, 3. 0.5 millivolts you can call.
Yes.
So the total is, this one is 0.1, but it has 200 divisions, 0.0001. It is quite comfortable. We are not leaving the single division here now. For that reason, it is quite comfortable to interpolate readings up to 1.5. 1.5 is nothing but 0.0005. This one divided by 5. It is nothing but 0.0001. We'll get that one. 5 कैंसिल किया तो 0.0001 आ जाएगा. दैट मच वोल्टेज इधर से 0 से 0.0001, 0.0002, 0.0003 like that we are going to move here up to 0.1 तक. 200 divisions को इसको हमने कंसीडर कर रहा है. दैट इज कॉल्ड सर्कुलर स्लाइड रिंग का हो गया. A potentiometer, this potentiometer is provided with a double through switch here now. Whatever I told that one, this is, you can connect into calibrate mode and we can connect into operate mode here now. So the potentiometer is provided with a double throw switch which allows the connection. Either standard cell को allow करते इधर, standard cells को allow किया ना ये use करने का. If it is connected to the operating mode, then it will apply to the unknown voltage here. Double throw switch which allows the connection either the standard cell are the unknown voltage to be applied to the working circuit. So a key, this one key is used here now, and protective resistance is used in the galvanometer circuit here now. Just for the galvanometer protection के लिए हमने ये circuit use कर रहे हैं. If the initially we are going to use this one, once the current is started, we can reduce the current and we have measured the smoothly it is operating, then we can bypass that one. We can bypass after the null position, we can bypass all the current into this galvanometer. Is it clear? In the calibrating mode, we are going to compare this one. This value will set and we will measure that one. In the operating mode, we are going to measure the unknown voltage and we can compare this value already known either 1.3 volt, 0.1 volt, 0.2, 0.3, already known voltage is there. We can compare with that one here. Now by measured value is compared with that here. Any doubts regarding this? If you have any doubts, you can ask. Any doubts? Yes. अभी पूछ लो डाउट क्या है बोल के. Before starting, this is the end of this galvanometer. Next we will go for the calibration of voltmeter कैसे करते, ammeter कैसे करते, power कैसे करते, power कैसे measure करते, वो we are going to do that one here now. Yes.
No.
No doubts. So we'll stop here only. Next tomorrow we'll discuss about the applications of the galvanometer. We'll discuss. So before that one, before stopping that one, today I have sent one message here now in the WhatsApp group. If you become a entrepreneur, if you want to become an entrepreneur, you can then register. Okay, type किया मालूम है? So SOBUS activity, those people, they are going to conduct the activities tomorrow. So if you people are interested, they will give the idea, they will check your idea. If your idea is working out, then you can move with them for the next year project and all the things. So interesting thing is that they have already tied up with our college. They are already available in our campus only. Okay, so if you want to get the guidelines from them, then you can register for that. Once if you register हो गए तो that screenshot you have to send into the proctor group. दोनों proctor group में send करो. Second thing, I told you people about the what is that vaccination details. Anyone have taken the updated vaccination list? वैक्सीनेशन अपडेट किए क्या? डबल डोज हो गया किसी का?
Yes, sir.
Then have you filled the form once again?
Okay, sir.
So who has already taken the double doses? If you have not uploaded the Google form, already link is there with you people. So search it and you have to, after taking the second dose, once again you have to fill that form. Once again, we have to fill that form. Then only I can understand that one. If tomorrow, if anyone, tomorrow we are not doing any hardware, actually I will do in the virtual lab only practical. If other subject, if you want to do the practical means you can come, and even at the 2 p.m. there is a SOBUS activity is also there. We can come also for that. SOBUS activity is there, offline is there, you can come. Otherwise, students, it is not compulsory. So first you register, then we will decide that one. If interested people, if you have an idea, good idea and all the things, otherwise also, if you want to involve in this activity, you can involve, you can register for that one here. Okay. So anything you want to discuss? Other things you want to discuss means you can ask. After so many days we are taking the class means I have missed so many, but today onwards regular will continue. There is no test, no practice and all the things. because of the some busy schedule in the college, we have planned for that one. Interruption occurred, but today onwards will regular classes will be engaged, theory lecture and as well as practical. सिलेबस किधर तक गए दूसरा सब्जेक्ट? ईडीसी ठीक है ना? अभी कुछ प्रॉब्लम नहीं? गोविंद डी पावर, your voice is not audible. You are trying to speak out, but your voice is not audible. Govind D power. I'm not getting anything. Okay. To stop here only. If anything is there, means you can let me know. And one more, very important, scholarship form. How many of you filled? Applied scholarship notice आया है, देखा है क्या? मैसेज में डाला था मैंने. Both the proctor groups I have forwarded the message. Hello.
Yes, sir.
हाँ. One by one. Have applied for the scholarship, and you are responsible. That is your amount. You people have to do that. घर में बैठ के करो. कुछ doubt है तो you can ask me. Can renew that one. Already have filled in the first year. Yes. Okay. The syllabus I will stop here and then just a minute. I will